This is an introduction to systems of equations. In particular, we will consider 2x2 linear systems of equations. As usual, we will begin with some definitions. A system of linear equations is a collection of two or more linear equations. A 2x2 linear system is a system of two linear equations in two variables. The first 2 refers to the number of equations, and the second 2 refers to the number of variables. A solution to a 2x2 system of linear equations is an ordered pair xy that satisfies both equations. For example, the point 2, 5 is a solution to the system of equations x plus y equals 7 and y equal 3x minus 1 because x equal 2 and y equal 5 make both equations true. Let's consider the graphical interpretation of a linear system of equations and of a solution. The graph of a 2x2 linear system of equations consists of two lines. For example, let's graph the previous system consisting of the equations x plus y equals 7 and y equal 3x minus 1. We start with a set of axes and a grid for scale. We graph the first line, perhaps using intercepts. We graph the second line from the slope-intercept form of a line. Finally, notice that the point 2, 5 is a point that lies on both lines. In general, a solution to a 2x2 linear system of equations is a point of intersection of the two lines. When considering the graph of a 2x2 linear system, there are only three possibilities. Two lines in a plane can be intersecting, parallel, or coincident. Coincident lines coincide or lie on top of each other. In each case, we have additional terminology. When we have intersecting lines, there is one solution to the system. When there is a solution to a system, the system is called a consistent system, and the equations are called independent equations. In the second case, when there are two parallel lines, there are no solutions to the system. A system with no solutions is called an inconsistent system. However, we still have two separate lines, so the equations are called independent equations. Finally, in the third case, where we have coincident lines, or two equations representing the same line, there are infinitely many solutions to the system. Because there are solutions to the system is consistent. However, because the equations represent the same line, the equations are called dependent equations.